All right, this is the notes number 3 for today. So it is an introduction to geometry and proofs. As I've been going over with the notes, I expect your name, date, period, always have a title, always set it up the way that my notes look. So mine are the model for how yours should be. The essential question, what key terms do I need to study and how do I do a proof? I don't know if you've done a proof before yet. Usually you do learn them in your previous math classes, but you may not have learned it last year. So I'm going to go over it. If it's confusing, just maybe watch the video one more time, listen to the instructions and the reasons. That goes for anything in the notes. Since it's a video, you guys can rewatch it. Anyways, we will do the daily math review problems in class. It's just practicing solving. So I'm going to skip that for now because you probably already did it. Hopefully you already set up your paper. Okay, so I'm going to move this on up. And here it's going to be kind of a lot of writing. I'm going to show some of the key vocabulary terms. If you want, pause, write them down. And then I am going to explain them. I'm just going to keep going. You guys pause whenever you need to. So I'm going to go over these 3 things because they relate to each other pretty well. Now would be a great time to pause. Okay, so a line has arrows on both ends. Those arrows, anytime there's an arrow, it means that it keeps going forever and ever and ever in that direction. So a line has arrows on both ends. We name it with any 2 points in any order. So I hope you guys can see this okay. I'm going to zoom in just a little more. We have line ABC. Well, the points on the line are ABC, but you only name it with 2 points. So even though you see 3, you can name it. I got a little sloppy here, sorry. You can name it with AB. And I didn't have room. You could name it BA. You could name it CA. Think about how many different ways could you name this one line. You only need 2 points to name it, but I put 3 points on it. And a line could have even more points on it. Okay, notice that the reason you know it's a line is because above the 2 letters, you actually have a picture of a line with arrows, an arrow on each end. So that is how you name a line. This is a line, like the actual diagram of a line, but in blue is how I would name it. Okay, the next thing is array. Array has 1 arrow and 1 point. At the point, it stops. It will never go beyond point D. But after E, there's an arrow, and that means it keeps going forever and ever and ever and ever. There's only one way to write this ray. You have to start at the end point, which is D, and then it keeps going at E. So I have to have the D first. Notice how above the D, it's kind of like a point. And then above the E, there's an arrow, just like over here. The arrow's with the E, the point is with the D. All right, so you'll get practice with these on alex.com. That's why I have all these key terms in your notes. For line segment, it doesn't have any arrows. It is not continuing in either direction. So there are points on both ends. This one, I just picked the letters F and G. I'm just going through the alphabet. So you have 2 ways you can name this. You could go FG or GF. So you can kind of tell with lines and segments, you could go kind of backwards. I would think of that as backwards, and that's fine. If you say segment FG or segment GF, I know you're referring to this. But over here with the ray, you have to start. The first letter is where the end point is. So even if it was maybe pointing in another direction, you start where the end point is. So there's only one way to name a ray. Okay, so those are 3 things. Remember to use highlighter as much as you want. Oops, as much as it's helpful for you, don't overdo it. So I would maybe just highlight that those are the key terms, but you can highlight other things as well. You'll see later in this note, I'll highlight different things. All right, here's 2 things that kind of go together. So I'm going to just show these, pause and copy as needed. We have equal. I know you guys know what equal means, but in geometry, we have to be pretty specific. Equal means the same measure, like a numerical value, like how 6 equals 6. So the reason that we emphasize that is because congruent or congruence is a similar idea, but it's a little bit different. So equal signs, of course, are looking like that. Congruent is like an equals with a little squiggle line on top, like a little wavy line. Congruent means the same size and shape. We talk about congruent figures, congruent segments, congruent angles. So there's a lot of times we talk about congruent, but we don't say equal. They really have a similar meaning, but there's that small difference that when we talk about equality, it's talking about a number. When we talk about congruent, we're talking about size and shape. And yeah, if we have congruent segments, like this one, like a congruent segment, you would think, yeah, they have an equal measure. And so that is something we'll talk about later. All right, here is the next thing. This is the segment addition postulate. So in geometry, in Math 2, Math 2 has a lot of geometry. There are postulates and there are theorems, and we'll talk about them as we go, but I just want to start like diving into this to get you guys used to it. The segment addition postulate is kind of like a rule. It's something that we know is true, and we don't have to prove it. We just can assume that we know that it's true. So if we have 3 points, A, B, and C, if they are collinear, which means they are all on the same line, which means like you could use a ruler to draw them and connect them. They're all on the same straight line. And B is between A and C. It doesn't have to be halfway in between, but just somewhere within this segment between A and C. Then AB plus BC equals AC. So the measure of segment AB plus the measure of segment BC equals the measure of AC. I'm going to use a little highlighter to show that. Blue is probably kind of dark. Let me pick a different color, maybe green. Good. So AB is right here. And when you don't have the segment symbol on top, that's when we talk about measure. That's why I kept saying the measure of AB. Plus the measure of BC. BC is right there. And I just kind of rewrote that equation right there. And then that would equal the total, which is AC, the big segment. It's basically saying 1 part plus 1 part equals the whole thing. So AC is the whole segment. So I hope the highlighter helps you a little bit to see how it relates. So again, AB plus BC equals AC. So just for example, and you'll have problems like this on ALEKS, if maybe AB is 10. I'm just going to write 10 just so you guys can see it. Maybe BC is 3. Well, what's the total length? You just add them. So I'm just going to write 10 plus 3 equals 13. What will happen is maybe you won't be given the BC, but it'll tell you the total length of AC is 13 and AB is 10. So sometimes you have to subtract. 13 minus 10 would give you 3. It just depends on which part is missing. Okay. Another key term you need to know is midpoint. A midpoint is in the middle of 2 points, which would be like in the middle in a segment. So you can see up above, B was not the midpoint because one segment was 10 and one was 3. If you have a midpoint, it makes 2 equal segments. So like, let's say the total length of a segment is 12. If I had a midpoint, it would cut it in half and make 6 and 6. Okay, so a midpoint is in the middle of 2 points. It makes 2 equal segments. And here's 3 that go together. So I'm going to just show both, or all 3 of those. And I'm just going to keep going. You guys pause the video whenever you need to. We've got right angle, acute angle, and obtuse angle, which you should know from previous math classes, but it's good to review it just so it's fresh in your head. A right angle, they're 90-degree angles. So if the measurement of the angle is marked, it would be 90. It looks like this, and we show it with a little box. Whoops, that looks weird. A little box on the angle. Okay, I made that look bad, but I think you guys get that. Acute angles are the ones that are smaller and less than 90 degrees. So 89 degrees would be acute, all the way down to 1 degree. Obtuse angles are more than 90 degrees, so 91 degrees and up. Okay, so that's one thing I wanted to go over for that. All right, the vertex. You may have heard of this before, but I want you to know specifically what is a vertex. It is the point formed by line segments or rays. So in an angle, you have a vertex. The vertex is this point, and it's usually named with a letter. So all the points are named with letters, capital letters. So in this example, M is the vertex of angle LMN. I'm going to use a different color just to show you. This means angle LMN. It's formed by two rays. Since they have arrows at the ends, these are two rays. Two rays that are like meeting at one point. And the point that they meet at is the vertex, and that is M. Okay. And again, you guys play back this video so that if you need to hear something explained again. If this is new to you, I would think it's kind of confusing. So I'm just assuming you guys know a lot of it already. We have two different kinds of angles. Complementary angles add up to 90 degrees. So you would have two angles, and they may not even be adjacent angles, which are touching angles. Like it could just be separate angles. Anything that's complementary means that they add up to 90. So like 45 degrees and 45 degrees are complementary, or 60 degrees and 30 degrees are complementary. If you're trying to find a missing complement, you would subtract from 90. So if something says, oh, these angles are complementary angles, and one of them is 20 degrees, you would take 90 minus 20 and get 70. I don't know why I grabbed pink. So then there's supplementary angles. It's a very similar concept, except the angles add up to 180 degrees, which is a straight line. Just so you know, 180 degrees is the degrees of the whole line like that, whereas 90 degrees, like we said, it's a right angle like that. Okay, so for supplementary angles, maybe one angle is 100. The other angle would have to be 80 to add up to 180. All right, and this is the last thing for this page of notes. And whenever you run out of space, just go to the next page. I tried to cram all this into one page. So we have an angle addition postulate. This is really similar to the segment addition postulate above, except this has to do with angles. And when you learn it, it should kind of feel like common sense, like, oh yeah, that makes sense. So it says, if point B is in the interior of angle AOC, then the measure, M is for measure, measure of angle AOB plus measure of angle BOC equals measure of angle AOC. And then I have a diagram down here. All right, so I'm going to use highlighter to make that a little more clear. So for one thing, it says if point B is in the interior of angle AOC. Angle AOC is this big angle, AOC. B is just some random point somewhere inside. It's not halfway. It's just somewhere in between in this angle. An angle is actually, it contains everything inside, like I could shade it in. That's everything within this angle. Okay, so you're basically breaking it down into the two parts of the angle, that the two parts add up to the whole. So I'm going to just highlight to show measure of angle AOB is right here, AOB. And then we have measure of angle BOC. I'll do in green. I'll just trace it to show you guys. So from B to O to C. And the arrows means it keeps going forever and ever. Okay, and it equals, if you add those two up, it equals the measure of angle AOC. So I go from A to O to C, like that. So basically, if you see the color enough, there. The yellow one plus the green one equals the pink one. That's a much easier way to say it. The yellow plus the green equals the pink. There we go. All right, let me just put some numbers in there though so it can make sense. Let's say the measure of angle AOB is 30 degrees, 30 degrees. And I'll say the measure of angle AOC, the big angle, what if that is like 50? I don't really know a good way to show that, but I'll just write it in here. If the measure of angle AOC is 50, but the measure of angle AOB is 30 degrees, then what would this one have to be, the measure of angle BOC? What would this missing angle be? So if I have 30 plus what equals 50? So I would just kind of do the math mentally. But if the numbers get more difficult, use a calculator. But you can tell it would just be 20 degrees. So this little one would be 20 degrees, and you can tell you add them up and it equals 50. All right, now would be a good point to pause and maybe stretch if you have just been writing the notes continuously. I'm going to just keep going, but you guys pause whenever you need to. So on my next page, it is, I'm going to cover this up. Okay, it is, like I was saying, you guys always title your page. So whenever you go to the new page, title it. So this is number 3, so it's note number 3 continued. Always have your name, date, period. Oops, date and period. Okay. So this is an introduction to a 2-column proof. I think 2-column proofs are the easiest way. There's also flow proofs, which flow with arrows, and there's also paragraph proofs, which you write out with words. I think those are kind of difficult. So as far as this introduction, we are just doing 2-column proofs. They're called algebraic. Algebraic means it has to do with algebra. We're going to do solving an equation. In your books, I'm going to show it. Page 41 has a list of properties of equality. So I'm just going to show it real quick. So it's 1-6. It's page 41. And it has all these different properties, which you should have learned in Math 1, but you may not have learned, which is fine. But some of them, it's like common sense, like, oh, addition property of equality. It just says addition property, but it's a property of equality. The distributive property I added to the bottom, it's not a property of equality. Properties of equality show things that can be done to both sides of an equation. You can add something to both sides. You can subtract to both sides, multiply to both sides, divide to both sides. But distributive property, you're not necessarily doing to both sides of an equation. I'll come back to distributive property. We're not using it today, but just so you know, there is a distributive property, and it is actually on the next page if you look ahead. Okay, so it is right there. Okay, so anyways, we're going to go ahead and complete the proof. So when you have any proof, there is a given and something that you have to prove. The given in this case is an equation. And the thing we're proving is x equals 6. You set up a 2-column proof like this. There's going to be statements always on the left. Reasons are always on the right. The statements and reasons are always numbered, and they should go like straight across from each other. So if I have a statement right here, number 1, reason number 1 goes across. If I have to skip some lines and statement number 2 is right here, then reason number 2 has to be like with it. So keep it organized. Always start off with the given statement. So I look up here and I just copy this equation. I'm going to just copy it. So 3x plus 12 equals 8x minus 18. The first reason is always given. So it should always be easy to start off a proof because it's right here. Your statement is whatever it is that's given, and then your reason is the word given. Always just write the word given. So for algebraic proofs, I would recommend to solve it on a separate paper. In your proof, like in this part, we don't show work. I know your whole life you've been told, show your work, circle your answers, all that. But in a proof, we actually don't show work, which is really weird. So I would work this out on a scratch paper or something and show my work. So looking at this, sorry, I got an email. Looking at this, I would, if you want, draw your line down the equals. I would get my x's on the same side. Bring down the 12 equals 5x minus 18. I want my numbers on the other side. I would add 18. Cancel that. And add it up. 30 equals 5x. Get x alone. Divide by 5. 30 divided by 5 is 6. So looking at my answer, 6 equals x. But the thing I'm proving is x equals 6. So the number is the same. I solved it correctly, but our final step, there is one more step. We switch them around, and that is called the symmetric property. When you just like switch the order. That's symmetric property. So anyways, we're going to write it all down. So now that I've solved it, I can see that this is my first statement. This is going to be my second statement. So I'm kind of skipping the work. This one is my third. This is my fourth. And this is my fifth. And I know how to do this because I've already done this once. So I can just look at it real quick. When you're doing one on your own, which won't be for a while, it might take a little while to look at it and see like where is each statement. Each statement is basically each step. Step 1, step 2, step 3, step 4, step 5. Okay, so I'm going to go ahead and write down my second statement. Remember, I had 12 equals 5x minus 18. So looking at the proof, you can see I'm not showing work. The proof is like formal. It's kind of like a final draft of an essay. You don't want to have any mistakes. You don't want to have it be sloppy looking. And then the reason's going to go over here. So when I'm thinking of the reason, I'm thinking, what did I do? What was done from this first step to the second? And I can see I subtracted. I did subtraction property of equality. I can't talk. Subtraction property of equality. And if you just look at this, you can kind of see like, oh, I can tell that the 3 was subtracted to the 8. Okay, so the next step, see how I had to write on that line? I'm going to skip so that they're on the same line. So 3, step 3, or statement 3. 30 equals 5x. I have to think what was done from the step 2 to get to the step 3. What was done from 2 to 3? How did I end up with a 30? You can also look and see, well, what has changed? Where did the 18 go? How did 12 turn into 30? And you can see in the work, that's why I say work it out first. 18 was added to both sides. So if it's added to both sides, that's addition. And there is a short way to write property of equality. I can write POE, which I think you guys will probably prefer. Addition, property of equality. So for subtraction, I wrote it out just to show you that's what POE stands for. Here, I'm just going to use the shortcut. Okay, so now moving on to statement number 4. That's why, I like that I number them here. That way I can follow along. I got 6 equals x. And then to think, well, what's the reason for that? I would look back at my work and think, what was done? What was done from step 3 to get to step 4? So you're always looking back one step and ask yourself, what was done? What was done? That's what I'm asking myself. What was done? Well, the 5 isn't there anymore, and the 30 turned into a 6. Looking at my work, oh, I divided by 5. So, again, you guys, sorry, I haven't really shown it, but I keep looking at this page 41. There's addition, subtraction, multiplication, and division properties of equality. So these are the ones that I'm looking at. Okay, so I'm not just making them up. I am actually like using the book. So my reason number 4, and I always want to number it and have it lined up across. What was done? Well, division by 5. Division, POE. So it's kind of like I was saying, you just have to ask yourself, what was done? Addition, subtraction, division, maybe it was distributed. Not on this problem, but in other problems, that's kind of what you're asking. All right, step 5. I'm writing the answer the way it was when it said to prove it. They want the x on the left and the 6 on the right. So for step 5, I would write x equals 6. And the reason is, let me write 5. Let me show you in the book, page 41. There's these 3 properties which are not really like the ones above. The ones above are like operations, like there's addition, subtraction, multiplication, division. These 3 are different properties. Reflexive property we will use later, not so much in these kind of problems. Symmetric property, look how it goes. If A equals B, then B equals A. It just switches the order. The A switches with the B. That is this reason right here. And then there's also the transitive property. It's saying like, okay, if A equals B, but then B also equals C, then A equals C. So that's where you'd have like 3 different things. 2 are equal and 2 others are equal, then the first equals the third one. That doesn't make sense right now, that's okay. We'll come back to it. There's also the substitution property, but that's not being used right here. Substitution property would be like maybe if I check my answer and make sure it's correct. There's other times we use it too, of course. So anyways, it is the symmetric property. Symmetric, and I can still put POE, property of equality. Okay, I think that's it. So if your notes are finished, that's great. If not, go back to whatever part you missed. Remember, you do need to have questions on the side. So the way my notes look, I would probably want, I don't want to, there. Okay, I would want like one question here and a second question here. It's not a full page though, so I don't need to have a third question. But what I do need to have at the bottom is a summary. Summary, and again, you guys, it's 3 sentences. It could be more, but it can't be less, okay? All right, so use these notes when you start your ALEKS assignment. ALEKS assignment number 3. You will have to use a lot of these key terms right there. And you know what? Just to model for you guys again, you should be interacting with your notes. So now looking back at it, I'm like, okay, so I see that when I do a proof, there's the given and the proof, and then I have my 2 columns like this. It's kind of like a T-chart. You always have statements on the left, reasons on the right. So a little bit of highlighting kind of helps to define that and make it maybe easier to use when you do need to use it. Just so you guys know, there is not a proof on the ALEKS yet, but we will be practicing more and more.